Okay, today's lesson 45. We're still doing systems of equations by elimination. But we're at the end now. Okay. Sometimes there's special things that happen, but let's look at the big idea. We're looking at graphing. Remember last semester we were graphing two lines, right?
Yeah.
That's a system when we have two different graphs to come together. It's a system. The answer is where the graphs what? Intersect. And then what's that point called that we?
Ordered pair.
Okay, what's it all called, everyone?
Ordered pair.
Ordered pair, okay. That point's called an ordered pair. Okay, so you have to have an x and a y, okay? So, graphing is sometimes tedious because you have to get your paper and you have to draw a nice straight graph and you have to find where they cross, and sometimes we make a mistake, it's not very accurate. So we use this way by elimination. We've been working that for the last few days, okay? So, we already know how to do that, and I think you could do it pretty well. So today we're going to look at special cases that pop up where you're working and you're like, oh, that's a weird answer. So there's two different answers that could be weird. So let me pull up the steps for today. So these two new steps, if your work ends up showing a number equal to a number, then you're going to have to write down this is your answer, infinitely many solutions, and I'm going to talk about why later. And then if your work ends up showing a number equal to another number, then you would write no solution, okay? Okay, so those are the two new steps. Let me show you number 1 right now. Number 2 is the same as number 1 here. I made a mistake. Okay, so you already know how to do this type of work, okay? So I'm not going to explain how to do it. We're just going to work out the problem like I normally would. So do you notice that my problem is organized or disorganized right now?
Disorganized.
Disorganized. So you're going to do what you did before. You're going to name these, and you want to reorganize it. So one way to reorganize it is just keep the first equation the same. Just make sure everything is together. So I got 2y minus 7 is equal to 9x. Okay, so on the first equation, I'm noticing y's come first, they're all together, then constants equal sign, and then negative 9x. So on the second equation, I want to make sure I have y's underneath here. So on the second equation, I'm noticing that on the equal sign, the y's are not on the left side, but on the right. So I need to add 2y to the left side, okay? So just to move it over. So we get 2y, okay? And it's positive 2y. Then I have constants here, negative 7, right? On the second equation, are there constants on the left-hand side? No, they're on the right. There's plus 7, so I have to move the plus 7 to the left. So how do I move plus 7 to the left? I have to subtract 7, right? Minus 7 on the left, okay? Then we have an equal sign. I'm going to bring that down, and then we have x's here. The x's are on the right side of the first equation, therefore they should be on the right side of the second equation. Are they here? No, they're on the left, okay? So I have to add 9x and put it here. Okay, now, in your head, what are you noticing already? Turn your neighbor. What do you notice about both of these equations?
They're all lined up in the same numbers.
Okay, so we're gonna keep working here, right? I wanted to eliminate the y's here because they were both the same. So 2y minus 2y eliminates, right? Negative 7 minus negative 7 is 0. Okay, I'm gonna bring down the equal sign. 9x minus 9x is also 0. Okay, so now we're at a weird place, right? Shouldn't I have had x is equal to something, right? Yeah, but instead I have 0 is equal to 0. Is that true? Is 0 equal to 0?
Yeah.
Yeah, good. So now I'm looking at I have to remember my steps. So look at step number 8. What does it say? If your work ends up showing a number equal to itself, then I have to write, it has infinitely many solutions. This is what I would write. So then on my paper, when I get to 0 is equal to 0, I'm just writing infinitely many solutions. Okay? That's it. That's what you would write.
Why would it be infinite?
We're going to talk about that. For now, just know this is what you have to do. In about 10 minutes when I get to the, I'm going to show you why, okay? Infinitely many solutions. Okay? Questions on what I did on number 1? Okay, so the big idea here is not the setup. I want you to know, but when you get to the end and you have a problem that ends off as the same number equal to the same number, what's the answer? Infinitely many solutions, okay? Okay, so I made a mistake on my lesson, so we're going to just have 2 solo ones about this one really quick, and then I'll do another example for number 2, okay? So 2s are talking right now. Talk about number 1 to your neighbors. What did I just do, and why is the answer the way it is? Ready, set, go. I'm going to do another problem. I want to show you the other kind of example, okay? So you don't know what your answer is going to look like. Sometimes it's going to look like this. Sometimes you're going to get an ordered pair. And sometimes it's going to look like number 4 here, okay? Actually, I'm going to skip number 4. Let me go to number 5 here, okay? Sometimes it's going to look like this, okay? So this is a big problem, right? Is it organized? Not quite. It's a little bit more organized, but I'm still going to name these 1 and 2, okay? So I'm going to take the first equation, bring it down. I have 5x, and I'm like, okay, cool. You know, it doesn't matter how you organize it. I like having the y's next to the x's, you see? You see how the y's are over here? I'm just going to add 10y over here. It doesn't matter, as long as you stay organized or together. Put the equal sign, and I have -6, okay? So that's my equation 1. I just rewrote it to make it look neat, okay? Now I'm going to take equation 2 and organize it. We already know how to organize it. So we have x's here. Are there x's on equation 2 on the left side of the equation? No, there's not. They're on the right. There's -10x, so I have to move it to the left. So I'm going to add 10x to both sides. Okay, so there's y's here on my first equation. On my second equation, the y's on the left side of the equation? Yeah, they are. So I'm going to add 20y. Okay, bring down the equal sign. And then the constants, yay, they're on the right side. I don't have to move them. Just bring them down -20. Okay? You should all know how to do this already, right? Good? Okay? And then I'm noticing that the x's I could get rid of, because if I multiply the first equation by 2, it's equal to 10x, right? And 10x and 10x would be the same. Do you all agree? Okay, so I'm going to multiply the first equation by 2. I'm going to make an equation 3 by using equation 1. So I'm multiplying it by 2, so I get 10x plus 20y is equal to -12. Okay? So I'm going to get rid of these x's, so I'm going to put a parenthesis here on the second equation. And I'm going to have to use a subtraction sign, right? 10x minus 10x would be eliminated, right? Would you agree? Okay, so that cancels out. 20y minus 20y is 0. Bring down my equal sign. Okay, -20 minus -12 is -8. Okay, so I'm here now. I should have had something like y is equal to something. But it says 0 is equal to -8. Now let's think about that. Does that make any logical sense? Is 0 equal to -8? No. It's illogical, right? Numbers cannot equal other numbers. It can't, like 0 doesn't wake up one day and be like, I'm tired of being 0, I'm going to be -8. It doesn't do that. 0 is always 0, -8 is always -8. So does this make any logical sense? No. So that last step, remember if the numbers are different, we would write no solution. This is the answer. Okay? No solution. All right, before you write this down, I want to see, do you have any questions on number 2? This is your number 2. Okay, so let's have 1s tell 2s. The 1s are talking. How did I do this? And how do you know it's no solution? The 1s are talking. Ready, set, go. Okay. We're doing this one is our number 3. Yep. Right after the lesson. Please remind me to do that, okay? I keep forgetting to do that. Okay. It doesn't matter because your seats are assigned to your iPad, so I have your names already, so it does matter because it's more official, but okay, so number 4 we got -6x minus 2 is equal to 2y. Okay, so work with your neighbor, and I want you to tell me, let's set this problem up. Tell your neighbor what you would do first. Go. Okay, so I'm going to name the problem first. This is problem number 3, but I would name each of these as 1 and 2. And an easy way to do this, let's just organize this. Equation 1, you got -6x minus 2 is equal to 2y. Okay? And you don't have to always organize equation 1. You could just leave it the way it is. Just make sure everything is together. Okay? Let me show you one more hint. Okay? For equation 2, on equation 2, don't just start here. Put the equal sign beneath the other equal sign. That way you know where the problem is, right? You know where the equal sign is. Okay. So there's -6x's here. Are there any x's underneath on this number 2 on the left side of the equation? Yes or no? No. So they're on the right side. We have negative 6x. So how should I get this negative 6x over? Add 6x to both sides, okay? Okay. Next we have, over here we have negative 2. Are there any constants on the left side of the equation on equation 2? Yeah, how many constants with numbers there? 1? No. What number represents the constants on the second equation? 2, right? So we're going to keep that there, plus 2. And then, of course, on the right side, we need to have 2y. We don't, so we're going to subtract 2y. Okay? So I'm going to put parentheses around here and put a line underneath. I want you to finish this problem. If you need help, work with your neighbor and figure out what you get to. I'm going to give you about a minute, okay? Go. Which is a great sign. So it's infinitely many solutions, right? 0 is equal to 0. That's true. 0 does equal 0 when you have a number equal to itself. It is infinitely many solutions. Okay? That's it. So that concludes this lesson. Now I want to talk to you about why this works, okay, on a graphing calculator.